now that we're working on solving proportions, is, that seems like it's out of focus. Let's try that again. That looks better. Okay. Just in case you don't know, on our little sheet of paper, if you see an M, it means meters. If you see an MI, it means miles. Make sure we know the difference between the two things. If you see OZ, that's going to stand for ounces, just in case. One thing that I want you to know when we talk about proportions is they are used a lot in real life with maps. Proportions are used a lot with maps and with cooking and with everyday things. We use proportions all the time. I used to cut my own lawn. And when I cut my own lawn, I had a lawnmower and I would have to cut my grass. And there was this thing I used called a weed eater. And as a part of the weed eater, you don't just put in gasoline into the weed eater I had. I actually had to put oil in the gasoline, mix it, and then put that into my weed eater in order for it to work. And if you want to know how much oil to put in, on the side it tells you what the ratio is to put in. How many drops or how many ounces you're supposed to put in per gallon. I want to say I used a 40-to-1 mix of gasoline in order to make that ratio work. That's a proportion. Proportions are also used in things like maps. Here's a little map of Buchanan High School on my cell phone. I pulled it up on Google Maps. Buchanan High School, right there. And if you have a class over here in the band room, and then you walk all the way over to the front office, band room to the front office, if you're wondering how far that is, you have to use this little thing at the bottom, which is called the scale. I don't know if you can see. Let me move this over to a baseball field. It says from here to here is 500 feet. So if I know how far 500 feet is, and I say it's from the top of my pin to here, then I can actually sort of go, okay, it's one of these, it's two of these, it's three of these. About how many feet is it from here to the front office? It's about two of them, right? It's about 1,000 feet to walk. That is not so far, because how many feet are in a mile?
4,000.
So you're not even walking a 0.2. That's how much that is if you're walking from the band room to the front office. It is less than a fifth of a mile, basically. So that's a real life example of how we use proportions in real life. What I want you to know about proportions is that the units should match. If I have blank inches on the map and it represents so many feet. Do you remember how many, like that little tiny, let's say it was, let's estimate here. Let's estimate. Let's go and break out this thing real quick. Gonna break out my ruler. It might be better to do this in centimeters. Let me do this in centimeters. 1.5 centimeters. Ooh, that's better. cm. 1.5 centimeters. 1.5 centimeters. That's what I measured. This little tiny thing down there. That's what I got. Is how many feet?
500.
500 feet. So far, so good. Equals. Now I want to measure from the band room to the front office is 3 centimeters. 3 centimeters equals X feet. These, I'm going to put a little arrow to it, these units should match. Centimeters over feet should match with centimeters over feet. It does not mean centimeters to centimeters and feet to feet. It means if I'm going this many centimeters is this many feet, then I can figure out anything as long as I have centimeters to feet on the other side. They should match with what's across from it. If I am doing this problem, what I can do is I can multiply this value times this value, and it is equal to 1.5x. I can also take the 500 feet and multiply it here to the 3 and set those two values equal to each other. What is 500 times 3? Good. This method that I'm using is called the cross products property. I'm using the cross products property, which says I can take this cross product, this times this, and set it equal to this times that. Can I actually figure out how far x is? Is this multiplying the x? What's the opposite of multiplying by 1.5? And if I put 1.5 into 1,500, I'm almost positive it comes out nice and even. Is 1,000 what? That's how many feet it is to go from the band room to the front office. Not too far. 0.2 of a mile. Yes?
I'm not sure if it works every time, but I think my teacher taught me this thing like there's a multiple between 1.5 and 3, and that's 2. You multiply 500 by 2, and you also get the same answer.
That works. But not all answers are going to be nice and whole. Some of our answers are going to be fractions. Okay? I recommend you use the cross products property most of the time. I recommend you use this property especially when there is a variable in the denominator. Cross products property. I want you to use it when there's a variable in the denominator. Let's look at this. 3 over x. Is the unknown value in the denominator? If it is, that's when we're going to need you to use the cross products property. It also works for negatives. Let me give you an example, and I'm going to put a number 9 right here in parentheses. This is going to look like number 9 on your worksheet. I'm going to use Q. That's a Q. Let me do a flat one, or I don't know which one you guys do, but that's a Q. I'll do a capital Q. That's easier to see. Capital Q over negative 15 equals 1 over 3. This is supposed to say capital Q over negative 15 equals 1 over 3. And I'm going to use the cross products property. I'm going to take the top left and multiply it by the bottom right. I'm going to do Q times 3, which is 3Q. And then what I'm going to do, and I'll do this in red, is going to be equal to this bottom piece times the top right, which is negative 15. Don't forget, product means multiply. We're multiplying these two things. Do I have Q by itself yet? What's next to it I need to get rid of? What's the opposite of? What am I going to do to both sides? That's my next question. Be specific. Divide by what? Good. And Q will equal what value? That's how we're going to do problems like number 9. Not all answers will come out nice and whole. I'm going to put a little side note over here. Some answers will be fractions. Some answers will be fractions, and that's okay. Don't freak out if you get an answer as a fraction. Let me give you an example like number 16. Number 16 says 2 over j plus 3. Paramo. What's up, man? Yes, she is. Okay, bye. Christina, Mr. Childs wants to see you in the student services. So I have 2 over j plus 3 equals 4 over 5. That's our problem for number 16. This is a little different. Why is it a little different? Because I have a j plus 3. And I need to warn you sometimes. You might have to add a something. And when we use the cross products property, don't forget some things are in parentheses when you don't see it. I'm going to put a little hint right here. Hint. The j plus 3 is in parentheses. Oops, you can't see that. Let me move this over. Hint. The j plus 3 is in parentheses. If you don't see it, this line right here means that this is a group. You're dividing by this whole group of j plus 3. In your order of operations, you have to know that that j plus 3 is in parentheses. So what that means is if I'm doing the cross product property, I do 2 times 5. 2 times 5. What is 2 times 5? 10. Tyler. Let me go to Tyler. 2 times 5 is 10. Stay focused, Tyler. And then I'm going to do this 4 times the j plus 3. And that j plus 3 is in parentheses. And I'm going to write it out like this. 4 parentheses j plus 3. Because some of you are going to forget section 1. Section 1 is on the distributive property. Do you remember how to distribute? Mm-hmm. Yeah. And that means that you don't just give the 4 to the j, you also give the 4 to the 3. It's like the donut rule. Remember that?
10 equals 4j plus
10 equals 4j plus 12. I agree with that. Do I have j by itself yet?
Nope, so you have to divide.
No. Caleb, what do I do next?
You subtract 10 on both sides.
Ooh, no, I disagree. Remember, we want to get the j by itself. The j is on the right side. Let's get rid of addition and subtraction first. Let's get rid of the 12. How am I going to get rid of the 12?
Subtract 12 on both sides.
Yes. We're not dividing. We're subtracting 12 to both sides. On the right side, we have 4j. That makes 0. What's 10 minus 12?
-2.
And then,
Now you divide by -2.
whoa.
Or sorry, 4.
We divide by what?
4J.
So what is J equal to? And this answer, J equals -1/2. The bigger number is on bottom. Don't forget, if you were to plug this in on your calculator and you have a negative in front of this whole thing, your calculator will put the negative in front and reduce it to lowest terms for you. You could also write this as a decimal, but you don't have to. I would also accept -0.5, but just leave your answer as a fraction. That's why we're taught you fractions in 5th grade and in 6th grade and so on. There's another property that we're also going to use. The other property is called the multiplication property. Property. Let me move this up a little. Of equality. Multiplication property of equality. The multiplication property of equality is where we do the opposite of dividing. I'm going to write that off to the side. Do the opposite of dividing. Multiply. We're going to use this or do this when there is a single variable in the numerator. When there is a single variable in the numerator. I'm going to show you what I mean after you're done writing that down. There is a single variable in the numerator. That's when we're going to use the multiplication property of equality. If I were to show you up here in this example that we started with, do I have an x in the numerator? Do I have a variable in the numerator?
No.
So I cannot use this method. If you have an x in the denominator, you need to use the cross product property. That's what we've been doing. But if it's in the numerator, you can use this other method. Let me show you the method. I'm going to put a little number 4 in parentheses right there. This is like number 4 on your worksheet. I have f divided by 24 equals 3 over 8. F over 24 equals 3 over 28. The multiplication property of equality says, well, I have a variable in the numerator, and this f is being divided by the 24. We can do the opposite of divided by, and we're going to multiply instead. Instead of us doing f divided by 24, the opposite of dividing by 24 is multiplying by 24. That's why I'm going to do this step in red. That way you can see what I'm doing to the problem. Instead of us dividing by 24, I multiply both sides by 24. And on the left side, on the top and the bottom, remember, just like the units in the previous section, they cancel out. The only way they cancel out when you multiply or divide is if one's in the numerator, one's in the denominator, just like conversions. So on this side we have 1f, which is just f. For those of you who are not good with fractions, what I'm going to recommend you do is I'm going to recommend you do 3/8 times 24 on your calculator. 3/8 times 24. For those of you who are advanced in here and you don't want to use the calculator, I recommend you do the 24 divided by 8 first. What is 24 divided by 8?
3.
And 8 goes into 24 3 times. And I have a 3 times 3, which is 9. Let's press equals to double check our answer. It is 9 on our calculator. And that's how else we could do that problem.